Well, hello, this is Mr. Doro. Today we're going to be talking about solutions. By the end of this, I'd like you to be able to identify the parts and properties of a solution and describe what happens during the solvation process. Honors Chem, this is found in Chapter 12. General Chem, it's in Chapter 16. Well, we need to start out by defining what a solution is. A solution is a homogeneous mixture. Now that means it's evenly dispersed all the way through. It has to be two or more substances in a single phase, and that just really means that they're evenly mixed. A mixture, remember, is not chemically bonded together. A heterogeneous mixture, you can have different parts in different areas, but a homogeneous mixture has to be evenly dissolved or evenly mixed all the way throughout. And there are two parts of a solution that you need to be able to identify. One of them is the solvent. A solvent is the thing that does the dissolving, and a solute is the thing that gets dissolved. And usually the solute is the thing that is the least in the mixture, and the solvent is the one that's the most. So you see in this mixture here, we have the solvent, which would be like the water, and the solute would be these little particles inside. Well, there are all kinds of different types of solutions, and solutions don't have to just be a solid dissolved in a liquid. You don't have to write these down, but I just want to give you some examples of some types of solution. This is an example of a gas dissolved in a gas right here, and so you can see that a lot of pollution, things going up in the air, and also some liquids in there too, but gas dissolved in a gas. A gas can be dissolved in a liquid, and so here's an example of like carbonated water. Carbon dioxide right here in the middle and water all the way around it. It can have that gas dissolved in a liquid. You could have a liquid dissolved in a liquid, and so that would be like cream and coffee like this, and maybe food coloring in water. There is a liquid dissolved in a liquid. You could have a liquid dissolved in a solid. This is a mercury and silver amalgam filling. And so liquid mercury is dissolved in that solid silver to make a filling for your teeth. And then you could have a solid dissolved in a liquid, just like salt in water or sugar in water. And you could have a solid dissolved in a solid. That is like 14 karat gold. That is two different metals that are dissolved in each other. There are also some other mixtures that might seem like solutions, but they're a little bit different. Solutions have to have very tiny particles that are dissolved, but there are things called colloids, and colloids are also heterogeneous mixtures. They have larger particles than the solutions, but they're still small enough to stay dispersed most of the time. And then there are suspensions. Suspensions are also heterogeneous mixtures, but they have larger particle sizes still, and usually the particles will settle right out. So why will some things dissolve each other and others don't? For example, why doesn't water do a very good job of getting grease off your hands? Well, the reason why is because of the fundamental rule, and you need to have this fundamental rule written down. The fundamental rule is like dissolves like. That means polar things will dissolve other polar things most of the time. And if they're nonpolar things, then they won't dissolve polar, but they would instead dissolve nonpolar things. Like dissolves like. Gotta know it. And here are a couple other terms that you have to know. Electrolyte or non-electrolyte. Well, an electrolyte is something that when it's dissolved in water, it will produce charged particles, and that means it will conduct electricity. So this one right here, we have salt that is dissolved in water, and salt will make these charged particles where you put a current through it, and the current will travel right through there. But this is sugar dissolved in water, and sugar will not produce those charged particles, and so therefore it does not conduct electricity going through it. I know what you're thinking. How come some things are electrolytes and some things not electrolytes? Well, we have to think about this process called solvation. Solvation is pretty much dissolving. And so I have a process here where we had solid sodium chloride, or salt, and that's what this S stands for, not salt, but solid. And we dissolve it in water. The H2O is just going right above the arrow right there. And this is what the process happens. Process is it makes sodium ions in an aqueous solution, and it makes chloride ions in an aqueous solution. That means dissolved in water. So here's how the process really works. We drop in the sodium chloride inside the water, and these little water molecules that are around here start to pull apart the sodium and the chloride ions. And as they do, they surround them with the positive and negative charges. The negative chloride ions get surrounded by the positive hydrogen ions on the H2O because it's a polar molecule. And the positive sodium ions get surrounded by the negative side of the H2O, which is the oxygen. And so we get this process called solvation. Solvation is where it breaks apart the ionic compounds and it surrounds them with the opposite charges that attract them. So now you're probably wondering, is there a limit to how much solute can be dissolved in a solvent? That's a great question. That's what this question asks. How much solute will dissolve in a given amount of solvent? That term is called solubility, how much you can dissolve in there. And it turns out to be temperature dependent. Of course, we know we can't take a 5-pound bag of salt and dissolve it in a teaspoon of water. That just wouldn't happen. We just get some wet salt at certain areas. But with this little graph here shows different ionic compounds, mostly ionic compounds. There is one that's not an ionic compound right here. But you can see what happens to the ionic compounds as the temperature increases. The solubility, which is usually in grams of solute for every 100 grams of water, the solubility generally increases. Now some of these really change with temperature, like this potassium nitrate. Look how that jumps up. But then we have things like sodium chloride. And sodium chloride stays pretty steady the whole way across. It does increase though. Really the only one that decreases is ammonia. Ammonia decreases, and that's because it's a gas actually. And usually gases will decrease with increasing temperature, while solids, ionic compounds, will increase with increasing temperature. Solubility is then related to something called saturation. Saturated means that it has taken all of the solute that it can at that temperature. And so you may have a solution that is unsaturated. Unsaturated means that it still has room to dissolve more solute in it. Or you may have a saturated solution. Saturated solution means that it has dissolved all it can at that temperature, and if you add any more to it, then it just won't dissolve. It'll just sit down here on the bottom. It actually goes back and forth in between, and some comes out of solution and some goes into solution, but we just can't see it happen. And then we get one final possibility. And that possibility is one of my favorite terms in all of chemistry. It's called a supersaturated solution. Supersaturated solutions do this. When you heat them up at a higher temperature, usually they'll dissolve more of the solid in it. And if you cool them down very slowly, then that solid will stay dissolved in it, but it's very unstable. Then if you do something like drop a little seed crystal in here, drop that in there, it'll make it so unstable that all of these other ones will start to come out of solution and it looks really cool. That's a supersaturated solution. Now the last thing I have for you on this video are factors affecting the rate of dissolving. That means how fast do things dissolve? And you can change that by changing a couple things. The first thing that you can do is on the solute, if you increase the surface area. If it's a solid or a big block of something, then you could crush it. And if you crush it, then what's going to happen is you are going to increase the area where the solvent can hit the solute, because solvation happens at the surface of the solute. And so if you have more areas for this to hit, then it's going to dissolve faster. The second thing that you can do is you can agitate it. Now this I know is what your little brother or little sister do to you, but agitating, what I'm talking about is stir it or mix it. And as you stir or mix, then you can see what happens is you bring these into contact with each other more often. You move this around so that more solvent can hit the solute. And then the third thing that you can do is you can heat it. And again, as you heat this, then everything's going to end up moving faster. They're going to have greater kinetic energy, and so when they move faster, they're going to hit the surface more often, make the proper collisions that they need, and they will dissolve faster. All right, those are the major things that you need to know. We're going to build on each one of these as we go through our unit on solutions. Have a great day.